So how exactly do we construct a confidence interval? So this is for population proportion, and we're going to use number 9 on our calculator sheet. So we're going to suppose that a simple random sample of size n is taken from a population, or the data are the result of a randomized experiment. A 1 minus alpha times 100% confidence interval for p is given by the following quantities. So again, this is your mean. If you think of it with your normal curve, then we go up and down your standard deviations and then multiply it by your standard deviation that you found for the sample proportion. Okay. Another way to write this is the point estimate, which is this, minus your margin of error. So this whole chunk is considered your margin of error, and then add it. It must be the case that n times p hat times 1 minus p hat is greater than or equal to 10, and n is less than or equal to 0.05 of your population n to construct this interval. Use p hat in place of p in the standard deviation. This is because p is unknown, and p hat is the best point estimate of p. So let's look at an example. In the parent-teen cell phone survey conducted by Princeton Survey Research Associates International, 800 randomly selected 16 to 17-year-olds living in the United States were asked whether they have ever used their cell phone to text while driving. Of the 800 teenagers surveyed, 272 indicated that they text while driving, obtained a 95% confidence interval for the proportion of 16 to 17-year-olds who text while driving. So let's first verify the conditions are met up above here. Okay, so the first one is check if it's normal. If it's normally distributed, then we are able to use the normal curve and figure out the level, the interval. So our n is 800. What is our p hat? Well, our p hat's going to be 272 over 800, which is 0.34. So 0.34 times 1 minus 0.34 is greater than or equal to 10. That's 179.52, which is greater than or equal to 10. So it is approximately normally distributed, and 800 is less than 5% of 16 or 17-year-olds in the US. All right, so let's use number 9. Stats test. Okay. Number of successes was 272. We want 800 is our sample size. Confidence level 95. You can do 0.95 as well. Either way, it will work. 0.307 is your lower bound, and 0.373 is your upper bound. So lower bound, I'm just going to denote as LB, was 0.307. Upper bound was 0.373. So to put this into words, we can say we are 95% confident that the proportion of 16 to 17-year-old who text while driving is between 0.307 and 0.373. So another way you could say this is we are 95% confident that the proportion of 16 to 17-year-olds who text while driving is between 30.7% and 37.3%. The width of the interval is determined by the margin of error. the margin of error, E, in a 1 minus alpha times 100% confidence interval for population proportion is given by E equaling this chunk, so it's just the last half. Or you can take the upper bound minus the lower bound, divide by 2. You can find the upper and lower by using number 9 that we just learned. So we found the upper and lower. I'd like you to find the margin of error for 95 and 99%. So for 95, that's going to be easy because we already found the lower and upper bounds. Upper bound was 0.373 minus the 0.307. Divide that whole thing by 2. 0.033 is your margin of error. And for 99%, we're going to go to run that test again. Instead of 95, it's just going to be 99. So 0.297 and 0.383 are your bounds. 0.383 minus 0.297. Divide that by 2. You get 0.043 for your margin of error. So as the sample size increases, what happens to the margin of error? Or you can think of your standard deviation. So the more or the larger your sample size is, the closer you're going to get to the population. So the closer to the population, the less error or margin of error that you will have. That should be decreases. And if the sample size is quadrupled, the margin of error will be cut in half. This is because your n is under a square root. So when you take the square root of 4 times your n, and this is in the bottom or the denominator with a whole bunch of stuff on top, the square root of 4 is 2. So this is really 1/2. So that's how you get that. If you aren't following me completely, that's totally fine. You can just know that this is the case.